So we're just going to talk about the extraction today. And if we're going to look at extraction, I don't know how detailed you have discussed this in your organic, okay? So whenever we do the extraction, the one involving the separatory funnel, how do we describe KD? Anyone? How do you define KD? Did you discuss this before? KD is what?
Dissociation constant po, sir.
Of what? Anong ratio niya? So we could say KD is the concentration of your material in the organic phase, okay, over the concentration in aqueous phase. Okay, so this dissociation constant, or we could say distribution coefficient, or the other thing that we have is a partition coefficient. What information does it tells us? So let's say if I have a value of KD, what does it mean? Let's say if I have a morphine, so if I have a value of around 6.0, what does it mean? So ano ibig sabihin kapag meron kang KD na 6.0? It is more soluble in the organic phase, or if you have equal volume, so most likely equal volume of the organic phase and aqueous phase, if you have morphine, so most likely you have 6 times the amount of morphine in the organic phase over the aqueous phase. So that's what the KD means. Okay, so if we're going to look at this distribution coefficient or partition coefficient, it is dependent on what? KD is dependent on
Solubility po.
the solubility or the so-called solvent system. Okay. So let's say if the K value of, say, still morphine in petroleum ether and water, okay, and then let's say the other one, it has a K value of 0.33 in diethyl ether and water. So what does it mean? Which one are you going to use in your system to extract more morphine? Or which solvent system are you going to use? Or how are you going to interpret this data? Okay, so if I'm going to select this solvent system, then I would say I would rather use petroleum ether and water compared to diethyl ether and water, because in the petroleum ether and water, I can collect, it's not necessarily you can collect more, but most of the morphine will go to the petroleum ether layer. But if it's a diethyl ether and water, most of the material will go to water. So when the K is less than 1, it means that the compound partitions into the aqueous layer more than the organic layer. So those are the information that you need to know about this thing. Okay. Now, this is not new to you because I think the Orgo is the one that explained this concept. Okay, so if we're going to look at the partition coefficient or distribution constant, okay, so whenever we have, okay, the way that we're going to look at this is just what? Molarity, okay, in organic phase over the aqueous phase. Or we could say, the one that you type, the solubility in organic phase over the solubility in aqueous phase. Okay, so we calculate the K using molarity and solubility values. So they are not identical because there's different equilibria that are involved. So the true K usually represent the equilibrium between aqueous and organic solutions, while the solubility data represent the equilibrium between a saturated solution and a solid phase. The two systems are related, however, the Ks are derived from the solubility data, which is should be similar to the what we call actual K. So for instance, if we have this what we call solubility, so ano natin yung caffeine? So in water, for every 1 gram, okay, you need 45 ml of water to be dissolved. For diethyl ether, for every 1 gram, you need 530 ml. Now for benzene, for every 1 gram, you need 100 ml. And then for chloroform, for every 1 gram, you have 5.5 ml. So which is the best solvent? Which is the best solvent? So all of them 1 gram, and this is the volume that you can use to dissolve 1 gram. So the best solvent is the chloroform. Okay. Now, at first glance, you could say the worst is what? The ethyl ether. Now, how do you usually do isolation of caffeine? Where do you find caffeine most of the time? Maybe coffee, maybe tea, right? So how do you remove caffeine from tea? Or how do you make decaf? So maybe you're going to use chloroform, but are you going to drink the coffee if the granules has been what we call the used with chloroform? So usually you use a supercritical fluid extraction, as I have discussed before. But in real life, if you're going to look at this, okay, whenever we have tea, we brew tea, we heat it. So what happened? Your caffeine is being extracted, okay, from the tea leaves into water. Okay. Now, usually in a laboratory experiment in organic chemistry where you isolate caffeine, so usually you have a water and an organic layer. Now, how are we going to represent the K? Let's say if we're going to use the chloroform and benzene. So how do we going to, let's say, get the K in terms of benzene and the K instead of a K of chloroform? And before we do the calculation, which do you think is a higher K? Because I'm trying to relate here the solubility with the K value. Solubility is not the same as the K value, but they said it should be related. So paano ko i-represent yung distribution coefficient or partition coefficient kapag benzene and kapag chloroform using the information given here? So I'm going to use the way I put it here. So for every 1 gram, I have what? If I have benzene, 100 ml, and then for every 1 gram, I have the water, I have 45 ml, right? So ano yung value ng K na makukuha ko? And then I do the same thing here. So for every 1 gram of caffeine, I only need 5.5 ml of the chloroform. And then for every 1 gram, I need 46 ml of water. So ano yung K na makukuha ko? Can you do the calculation? So how do you solve this? What's the K value here? And what's the K value here? So you get 0.45. And around here is around 8.18. And this is another way of saying that chloroform is a better solvent to extract caffeine compared to benzene. But whenever you choose the appropriate solvent, you also have to consider what? Toxicity. Okay? Chloroform is usually carcinogenic and it's not the best option despite its high solvation ability. Okay? So this is just telling you the information that you can get given the solubility of a particular substance. Now, the next thing that we're going to do is, let's say we're doing this single extraction versus multiple extraction. Okay, so let's say we have a solubility data of a particular compound. Okay, so we have what, 0.5 grams of a sample in 150 ml water. So that's the solubility. And you have to, and you're going to be extracted it with 150 ml diethyl ether. So how much do you think of diethyl ether will go? Okay. So if you're going to look at the solubility of what we call the diethyl ether, so it's 1.44 grams per 100 ml solvent. Now in water, we could say it's 0.354 per 100 ml solvent. So this is water. This is diether. So if we have 150 ml water that contains this 0.5 grams of the sample, how much are we going to get for a diethyl ether? So maybe the first thing that we're going to do is what? Solve for? Ano yung una nating sa solve? We're going to solve for K. We're not going to solve for C1V1 value here. Remember, the behavior that you have here is this 150 ml, ayan yung nasa set panel. Right? And what we're trying to do here is how much of the 0.5 will go to the diethyl ether and how much of them will remain in water. Nagkakaintindihan ba tayo doon? It's not C1B1. You're trying to what we call, okay, I have this extra 0.5 grams of 150 ml water. So if I put a layer of the organic solvent, how much will the distribution be? And this is the solubility that we know. Okay, so all you need to do is determine the K. So that's 1.44 divided by 100 over 0.354 over 100. And this is equals to 1. Okay, so 4.07. So what does it tell us? So it tells us that diethyl ether will have more of your compound compared with water. And that is true based on the solubility alone. Now, the thing that we know we're going to do now is how much of the 0.5 will go in diethyl ether and how much of the 0.5 will remain in water. So paano natin ano to? So we have what? 4.07 here. And then we could put X over 150, right? Tapos yung isa is, how do we represent? 0.50 minus X, so if ever we do it like that, divided by 150. Gets? Nakuha ba? So based on this alone, so the value of this is 4 times compared to that one. So maybe we could say, oh, 0.4 grams over 0.1 is equals to 4, right? So you can do the calculation. Sinabi nyo, magician ako. Gaya ng mga estudyante ko dito. Professor, you can do magic. You can do anything that you desire. Tuwa ba? Tanong. So everyone convinced it's 0.4? So how are we going to interpret this one? So if we have the 0.5 grams that's in water, when we do the liquid extraction, 0.4 of that will go to the organic layer and 0.1 will remain on the what we call aqueous layer. Now, the question that I'm going to ask is how many percent was extracted? How many percent was extracted from the aqueous layer to the organic layer? Okay, so you can just put it as 0.4 over 0.5 times 100. So you have 80%. Now, how are we going to compare it, let's say, with a multiple extraction? Because sometimes a single extraction is enough. Okay. A single extraction is what we call enough to effectively extract a compound. However, more often than not, okay, procedure calls for a solution to be extracted multiple times in order to isolate a desired compound, as this is more efficient than a single extraction. Okay. So when you do a multiple extraction, what do you do? So if you do a simple, what we call a multiple extraction here, so instead of using a 50 ml, maybe you can make it like what? 150 ml. So 50 ml and then another 50 ml and then another 50 ml. And then you're going to combine all of the solvent that contains the extracted material. So if we're going to look at this in multiple extraction, the first extraction is just similar to the single extraction. And in the second extraction, what happened is the aqueous layer from the first extraction is returned to the separatory funnel with the goal of extracting the more additional compound. Okay. So the difference here, in the first extraction, your organic layer reached the so-called equilibrium with the aqueous layer. So it can do only little, okay, to return it and expose it to the aqueous layer. However, if you have a fresh diethyl ether, okay, it has the potential to extract more compound. And then you just repeat it, okay? But if you're going to do the multiple extraction, there's also a limit. You cannot what we could do it infinitely. Because what really happened, if you're going to graph, so maybe the first extraction, this is the amount, and then after the second, the third, okay, it will level. So what does it mean? After multiple extraction, you have already extracted all materials from the aqueous phase. Okay, so let's try to use the same problem that we have here. So we have the 0.5 gram in 150 ml water. And what we're going to do is we're going to do some extraction. But the thing is, instead of 150, we're going to extract it with what? 3 times by 50 ml. So paano gagawin natin dito? So 4.07 equals to x over 50.50 minus x over 150. What do you get? Do we do magic? Do we do anything to do some magic? Yes, the water is still 150 ml because that's where you're going to get the source. The one that you're going to what we could replace is just the organic layer, because instead of 150, you're going to extract it 3 times. So the same volume, but you're going to extract it 3 times. So the first extraction, that what does it mean? You get what? 0.29. So after the first extraction, how many was left there in the aqueous layer? Meron kang 0.21, right? And then you do it again. You add the fresh amount. So x50, this is what? 0.21 minus x over 150. So this is equals to second extraction. So that means x is what we call 0.12. So after the second extraction, how many was just remain? 0.21 minus 0.12. So you still have what? 0.09. And then you're going to add another fresh 50 ml. Ilan na lang yung natira? So you have what? 0.05. So in the end, you only have what? 0.04. So if you're going to ask what's the percentage of the material that's extracted, how much is that? So you have what? 0.46 over 0.50 times 100, right? How many percent is that? So you have 92%. So this is the case wherein you could show that multiple extraction will give you more amount that is extracted compared to single extraction. Question. Excuse me. Question? Pregunta. Tanong? Tanong? Sa atin. May tanong? May tanong, class?
None po.
Tanong? Bago tayo mag-quiz about this, may tanong? So, walang tanong? So, I already posted the links for Module 3 and Module 4. So, next week, Tuesday, you're going to have the Chapter 2 quiz. And then wait for me, whatever happened on, not Tuesday, Wednesday there, Tuesday here. And on Friday next week, whatever happened, wait for me, okay? There is a program that should end at 11:25, but knowing Filipino time, it might end around 12. But whatever happened, okay, wait for me. Because once I'm done there, I'm going to meet you in class. Unless it goes until 1. So by that time, you wait for message in FB. Okay. The experience that I have, I don't know. Whenever you have a meeting, if it's Filipino, the meeting can go endless. Here, whenever we have a meeting by 1 o'clock, with 1 hour, we're done. So the original time for the event wherein I am involved is from 11:05 to 11:25. But my experience with that event, okay, especially if it involves our own kababayan, it can start late and most likely it will end late. Ewan ko, ba't ganun? So just keep in touch with the what we call the Facebook messages for next week. So there's a quiz for chapter 2 on Wednesday, and we're going to start late on what we call Friday. Okay. Question?
None po.
Okay. So I'm just trying to what we call make sure that the quiz. So I'm just trying to look at the preview. Baka pumalpak na naman. So there's a 4 true or false question. I'm giving you 5 minutes for that. Okay? So I think it's 14. So I'll give you until 1 o'clock to finish that. So save and publish. So please see if you can see it now. Kita nyo na ba?